Hello teacher. So today I will be presenting on Amazon EKS, which stands for Elastic Kubernetes Service. Our focus for this seminar will be on how to run Kubernetes at scale on AWS, exploring real architectures, use cases, and the deployment patterns. So first, let's define what Amazon EKS actually is. It's an AWS fully managed Kubernetes service. The core value proposition is that AWS runs the complex control plane while you focus on managing your worker nodes or even go fully serverless by using AWS Fargate. Here are some key facts. Launched in 2018, it has become one of the most widely used Kubernetes platforms globally. AWS manages critical components like etcd, the API server, and the scheduler. It is a certified Kubernetes conformant service, which means your workload can be moved without vendor lock-in. It offers a high SLA of more than 99% uptime for the control plane and integrates natively with the AWS ecosystem, including IAM for security and VPC for networking. So to understand why EKS is so popular, we should compare it to a do-it-yourself Kubernetes setup. In a do-it-yourself scenario, you are responsible for managing the control plane, performing manual upgrades, and handling complex etcd high availability configurations. With EKS, AWS takes over the control plane management, offers one-click upgrades, and automates both etcd, HA, and security patches. This significantly reduces your operational overhead. So this diagram shows the clear division of responsibility in an EKS environment. The AWS managed section contains the brain of the cluster, including the API server and the etcd. In your own AWS account, you manage the worker nodes. You have three flexible options here. Those are managed node groups for automated EC2 scaling, self-managed nodes for custom configurations, or Fargate for a seamless experience with no nodes to manage at all. The entire cluster is tied together by native integrations like ALB Ingress, Secrets Manager, or CloudWatch for observability. EKS powers some of the most massive systems in the world. Shopify uses it to isolate millions of merchant storefronts and handles massive Black Friday traffic spikes using the cluster auto-scaling. Epic Games run the backend for Fortnite, scaling posts rapidly to handle matchmaking for over 350 million players. Moderna accelerated their mRNA vaccine research by running complex genomic pipelines on EKS, which specialize GPU node groups. Other leaders like ASOS, Twilio, and Capital One rely on EKS for everything from migrating monoliths to ensuring strict financial compliance. So here is how a production-grade microservices project maps to EKS. Traffic will flow from the client to an AWS ARB and an ingress controller to an API gateway port. Behind that, individual services like product, order, and inventory run in their own pods, communicating with databases like MongoDB or messaging systems like Kafka. We also run a full observability stack, including Prometheus and Grafana, at ports within the same cluster to monitor everything in real time. For a production environment, EKS provides several advanced features. Like scaling, we use the cluster autoscaler and Carpenter a modern provisioner that is 3 times faster at adding nodes when demand spikes. For security, IRSA, that stands for AIM roles for service accounts, allow us to give specific AWS permissions to individual pods without using static credentials. For networking, the AWS VPC CNI ensures each pod gets a real IP from your VPC for high performance. And finally, the storage, we use CSI drivers to connect pods to persistent storage like EBS or share EFS volumes. To set up EKS, we will provide a quite simple that consists of 4 main steps. The first thing is to install the necessary tools like AWS CLI and EKS at CTL. The second step is to create cluster with a single command, that is EKS CTL create cluster, provisions the control plane, node groups and IAM roles automatically. The third step is to deploy the workloads using a kubectl apply to deploy your application YAML files. And the final step is to configure add-ons. That is to install essential tools like ALB ingress controller and cluster autoscaler. So why we choose EKS in 2026? Because it drastically reduces operational burden. It provides lightning fast scaling with Carpenter. It offers deep integration with the entire AWS ecosystem. And most importantly, it's the industry standard used by giants like Netflix and Airbnb. Thank you for listening.